we give a simple proof of the Pythagoras theorem. Pythagoras theorem states that in a right-angled triangle of sides A, B, and C, the square on the hypotenuse equals the sum of the squares on the other two sides. Triangle MNP is a right-angled triangle which is given. Its sides are A, B, and C as marked. C is the hypotenuse, A and B are the triangle's sides. Angle PMN is the right angle. So this is the right angle. MNP is the given right angle triangle. Now we do the following construction. Draw a square of side A plus B units. Call it PQRS. A and B are the sides of the given triangle MNP. A, B are given sides. So we draw a square whose side is equal to A plus B. And the square is called PQRS, the big square that we're showing here in this diagram. Now on each side of the big square, mark off a point at length A units from vertices P, Q, R, S in that order, and call the marked points P prime, Q prime, R prime, and S prime. That is, from P, mark off a point P prime, which is A units from P. Likewise, mark off a point Q prime from Q, which is A units from Q. From R, mark off a point R prime, which is A units from R. From S, mark off a point S prime, which is A units from S. And we join the points P prime, Q prime, R prime, and S prime and obtain the quadrilateral. Now we show that P prime, Q prime, R prime, S prime constructed in the manner described is actually a square. Now there are four triangles which are shown in yellow fill. Each of these triangles is congruent to the given triangle MNP. And that can be shown by applying the right side angle side property over this given triangle and the given MNP triangle. So apply the side angle side property for each of these triangles and the MNP triangle, which is this one. This is the given MNP triangle. So each of these triangles is congruent to the given MNP triangle. Also, applying the condition that the exterior angle of a triangle equals the sum of its interior opposite angles leads to the conclusion that each angle of P prime, Q prime, R prime, S prime is actually 90 degrees. So the side of the P prime, Q prime, R prime, S prime is equal to C units from step 1. And one of the angles on each of the angles of P prime, Q prime, R prime, S prime is 90 degrees. So it follows that P prime, Q prime, R prime, S prime is actually a square. Now, for the proof of the Pythagoras theorem, so PQRS and P prime, Q prime, R prime, S prime are squares. So the area of PQRS, area of the big square, must equal the area of the small square plus the areas of four right angle triangles. So area of PQRS equals area of square P prime, Q prime, R prime, S prime plus 4 times the area of each right angle triangle. So we write them down as A plus B whole squared equals C squared plus 4 times half of AB. And upon simplification, we get A squared plus B squared equal to C squared. So which is what we had to prove. This is